All right, welcome back. Today, we're going to dive into some really cool ideas from a deep reinforcement learning lecture. We're looking at two huge strategies that are making AI way smarter and, more flexible. It's all about how machines can learn to imagine and how they can master hundreds of skills at once. Let's get right into it. So, to get us started, let me just ask you a couple of things. First, what if an AI could practice and get better inside its own head, its own imagination, without needing to try things over and over again in the real world? And second, what if we could build just one AI that could become a master of all sorts of different tasks, instead of building a totally new one for every single problem? Now, these might sound like science fiction, but believe me, they are the core challenges that AI researchers are wrestling with right now. Okay, so here's the game plan for today. We're going to start with what I'm calling the imagination engine. Then we'll get into the generalist revolution. After that, we'll look at this absolutely brilliant trick for learning from what you might call happy accidents. And finally, we'll pull it all together and see how these two pathways are creating the AI of tomorrow. Right. So our first pathway is all about giving AI an imagination. The official term for this is model-based reinforcement learning, or MBRL for short. But the core idea isn't really about some super complex new algorithm. It's about a much simpler concept: giving an AI the power to build its own internal mental model of how the world actually works. So what does that actually mean in practice? Well, the AI basically learns the rules of its environment. The physics, cause and effect, that kind of thing. And once it has this internal model, it can use it like its own private little video game, a simulator. It can dream up scenarios, it can try out different actions, and see what would happen, all without ever touching the real world. It generates tons and tons of practice data for itself. It's literally an imagination engine. So how does this whole loop work? Okay, first, the AI goes out and collects just a tiny bit of real-world data. It then uses that experience to update its internal model of the world to make it a little more accurate. And then the magic happens. It imagines thousands of short scenarios inside that model, creating this massive amount of synthetic practice data. And finally, it learns from both the real stuff and the imagined stuff. This is a total game changer, especially for things like robotics, because it massively cuts down on expensive, slow, and sometimes pretty dangerous real-world experiments. Now here's a really critical detail. These little imagined scenarios, or rollouts, they have to be short. So why is that? Well, because the AI's model of the world, it's not perfect, right? It's just an approximation. And if it tries to imagine too far into the future, tiny little errors in its model can start to compound and snowball. Pretty soon, its dream would drift so far from reality that it's just total fantasy. So keeping the practice session short and focused keeps it grounded. This brings us to a really important question. When should you actually use this approach? So model-based RL is fantastic when the world's rules are simple, but the goal you're trying to achieve is really complex. Think about a maze. The rules are super easy. You can't go through walls. But finding the exit, that's hard. But it's a terrible choice when the world is crazy complex and the goal is simple. Take pouring water. The goal is easy. Get water from here to there. But trying to accurately simulate fluid dynamics, that is incredibly difficult. It's just way easier for the AI to learn that simple wrist motion directly from real life. Okay, let's switch gears and talk about our second pathway. If that first pathway was all about making learning more efficient, this one is all about making it broader. We're talking about a fundamental shift from specialist AIs that only do one thing really well to generalist AIs that can do many, many different things. And the big idea here is, honestly, it's surprisingly simple. Instead of training a dozen different AIs for a dozen different jobs, you train one single, super flexible system. So how do you tell it what to do? Well, you condition it on the task. You can literally think of it just like giving a prompt to a large language model. You give the AI the state of the world plus a task description, something like open the drawer, and it figures out the right actions to take. And why is this so incredibly powerful? Well, for starters, it's way more data efficient. The skills you learn for one task, like how to balance while walking, directly help you learn how to run. The knowledge transfers. Second, it starts to understand shared structures. A robot that learns how to open one type of drawer can generalize that skill to other drawers. And here's the real kicker, and maybe the most surprising part. These generalist systems often end up being more reliable and even better at individual tasks than a specialist AI that was only ever trained on that one thing. It's a huge leap towards the kind of adaptable intelligence we see in the real world. Now for what is, I think, my favorite part. Hidden inside this whole multitask learning idea, there is this incredibly clever and just intuitive trick for squeezing every last drop of knowledge out of every single experience. It's all about learning how to turn your failures into successes. So let's set the scene with this great hockey example. Imagine an AI is learning to play hockey. Its current ask, its prompt, is shoot the puck into the net. Pretty straightforward. It winds up, it takes its shot, and it misses. The puck goes wide. So from the perspective of its original goal, shooting the puck, this was a complete and total failure. But in missing the net, it accidentally made a perfect tape-to-tape pass right to one of its teammates. This is where the magic happens. The technique is called hindsight relabeling. The AI looks back at that so-called failed shot, and it says, wait a minute, in hindsight, that wasn't a failed shot. That was a brilliant pass. It then relabels that entire experience with the goal, pass to teammate, and stores it in its memory as a successful example of passing. It learns from every single outcome, no matter what its original intention was. Just brilliant. Of course, this amazing trick only works under a few specific conditions. The physics of the world have to be the same whether you're shooting or passing, which makes sense. The AI needs to be able to do the same kinds of actions in the same environment, and crucially, it needs to be using what's called an off-policy algorithm. So think of it this way. An on-policy learner is like a chef who can only learn from the specific recipe they are trying to follow right now. An off-policy learner, on the other hand, is like a chef who can watch someone else cook a totally different dish and still learn a new technique from it. It can learn from experiences that weren't aimed at the goal it's currently focused on. So, there we have it. These two incredible pathways, the imagination engine for super efficient practice and the generalist revolution for learning a huge range of skills. And it's really important to see that these aren't competing ideas. They are totally complementary strategies that are building toward a much, much smarter kind of AI. To really put a bow on it, the imagination engine gives an AI the ability to practice, to hone its skills over and over in a safe, simulated world. The generalist revolution gives that same AI a rich curriculum, a whole library of different subjects to master, which lets it find connections and transfer knowledge between them. When you put them together, you get a learner that is just worlds more efficient, versatile, and robust. And that really just leaves us with one final thought to chew on. What actually becomes possible when we have an AI that can not only dream up new ways to solve a problem, but can also look back at every single thing it's ever done, even the mistakes, and pull a valuable lesson from it? That combination right there, that is what's truly shaping the AI of tomorrow.